Hi everyone. This is going to be a credit recovery unit test. This is part 2, and we are going to cover specifically polynomial terminology right here and sum and product of rational and irrational numbers right there. Okay, so let's get going. The first assignment we're going to do is polynomial terminology. All right, I see the first thing it says, what is the y-intercept of this polynomial? All right, so we have to know a little bit about that, and in the blog, I have put this little primer in there on polynomial terminology. All right, and so we can see that it describes the term, and so those are things separated by a plus or a minus. The degree is the highest exponent. So in our example here, we have an exponent of 4 and an exponent of 2, and that would mean it's a degree 4 because 4 is the highest exponent. All right, and then the leading coefficient is the number in front of the highest exponent. So that's a 3 here. And here we see the y-intercept. So the y-intercept is the constant. If there is no constant, the y-intercept is 0. Well, let's look at our problem really quickly over here. And we can see that this function, negative 7 x squared plus 10 to the x, does not have a constant. It doesn't say like plus 3 or like our example, minus 8. All right, so this one turns out to be a pretty easy one. So the y value is going to be, write the y value only. I think that just means we put a 0. Let's try that as our answer. Yes, our answer is 0. And that's the right answer. Okay, so let's go back. Let's do our next problem and see what we can figure for our next problem. All right, this says, what is the leading coefficient of the polynomial? All right, so let's look over here at our polynomial, which is 3x to the 4th plus 5x squared plus x minus 8. And we can see that it says the leading coefficient is with the highest exponent. All right, so we'll get our... All right, and I want to point out something else it says here. It says that the leading term, in other words, the first term you see is not always, the leading term is not always the first term. So it can be a little confusing, okay? And we see that right here. So here we have an exponent is 2, and here we have an exponent is 6. So we said that the degree and the leading term were with the highest exponent. Okay, so that's going to be 6. Now, we're looking for the leading coefficient. All right, and so in this case, the leading coefficient would be the number that's in front of this x to the 6th. All right, now, so we don't see a number there, but that's our famous invisible 1. The famous invisible 1. So our leading coefficient is 1. All right, so we're going to put a 1 in there. Submit answer. And green check. Okay, we're doing great. Let's do another one. Oops, I went back too far. Polynomial terminology. All right, let's do one more. What is the leading term? Okay, so the leading term. All right, so we said back here that terms were things that were separated by pluses and minuses. Okay, so here we have a negative sign, so that gives us 2 terms in that case. This one is 9x minus 10. So this is a term, this term, there's 2 terms in this case. The leading term is going to be the one with the highest exponent. Well, this doesn't have any exponent at all. There's no x value here. All right. So there's no x value there. So this must be the leading term right here. All right, so that's the leading term. So that's 9x is going to be our leading term, 9x. And we'll say yes, and we get another check mark. All right, so let's do 4 since it says to do 4. Whoops, I went back too far. Let's do 4. It says to do 4. All right, it says what is the leading coefficient? All right, so leading coefficient, so we have 9x cubed, 7x. So first we need to find which one is the leading term. Which one is the leading term? All right, so the leading term is going to be the highest exponent. Well, this has an exponent of 3. This one we don't write it. This has an exponent of 1, an invisible one, yet another famous invisible one. All right, so this is the leading term. All right, because of highest exponent. All right, and then it says, what is the leading coefficient? All right, so the leading coefficient, this is a coefficient, a number in front of a variable. All right, so the leading coefficient is going to be the coefficient for the leading term. Coefficient is the coefficient for the leading term. All right, which in this case is 9. All right, so we just need to put a 9 in here and we're good to go. Okay, so those are pretty straightforward, and I really encourage you to go to the blog and look at these notes that are there for polynomial terminology, and then also for the next thing we're going to do, which is radicals. All right, let's go to sum and product of radicals. All right, so this says find the sum of those two things. All right, so first thing, let's look over here, and let's look at sum, adding and subtracting. Sum is adding, right? So it says adding radicals is similar to adding and subtracting fractions. So where fractions have the same denominator, radicals have to have the same number. Okay, so we can't add 12 and 5, and 3 in this case, because 12 and 5 are not the same. Okay? All right, and so then can we go back to simplifying 12? In other words, are there any perfect squares on the inside? And there is in this case. A 4 is the perfect square on the inside. All right, but when I look over here, also determine whether it's rational or irrational and explain your answer. All right, so it looks to me like we can't simplify the 2 or the 5. There's no perfect square in there. So our answer is going to be the sum, which is adding. So we're going to have 4 square root of 2. Use my arrow to get out from underneath there. Sum, that's plus the square root of 5. Okay, all right, so that's our answer for that part of it. All right, now it says the result is, I didn't put irrational or rational numbers here, but an irrational number is a number that doesn't have a perfect square. All right, so 2 does not have a perfect square. 5 does not have a perfect square. Both of those are irrational numbers. So if you're adding irrational numbers, the answer is going to always be irrational. And because it cannot be written as the ratio of 2 integers, and its decimal expansion does not terminate or repeat. All right, so the square root of 2 and the square root of 5 are very much like pi. All right, pi just goes on forever and ever, and so therefore it can't be made as a ratio. All right, so we're going to submit that as our answer. That's a pretty long answer. All right, and let's see what we get. Yes, that was correct. All right, So this cannot be further simplified. Let's do another one and see if it can be simplified first. All right, so we're going to look at, clear our scratch pad here. All right, so we're going to look at this, and it says find the sum. So can we add 2 to the 5th, and can we add 3 to the square root of 16? All right, so 5. So our first thing is, are there any perfect squares? Are there any perfect squares under the radical? Under the radical. Okay, so is 5? 5 is not a perfect square. All right, but 16 is a perfect square. Is a perfect square. 16 is a perfect square because it's the product of 4 times 4. All right, so that would mean that the square root of 16 is equal to 4 times 4, which is equal to bring a 4 to the outside. Okay, all right, so that means that we can change this 2 to the square root of 5 plus 3 times, we can change this to 3 times 4. All right, so we have 2 plus, and now we have a 12. So that's our answer, plus 12. All right, now we can't add the 12 and the 2. It's just sort of like saying 2x plus 12. We couldn't add the 12 and the 2, but that's our answer. So we're going to go 2 square root of 5 plus 12. All right, now, is it rational or irrational? Well, 12 is a rational number, but 2 times the square root of 5 is an irrational number. So when you add a rational and an irrational number, you're still going to get a rational number, irrational number. So the result is irrational. So anytime you see one of these little square root jobbies here, that means it's irrational because it cannot be written and it does not terminate or repeat. And that's our answer. Okay, so we're seeing that the second part of this, which seems a little complicated, is actually pretty easy. All right, we'll do one more of these, even though we don't have to. All right, and we're going to get 3 square root of 25 plus 3 times the square root of 6. All right, now first is 25 is a perfect square, and 6 is not a perfect square. All right, but we can change the square root of 25. That's equal to 5 times 5, which means it's equal to 5. All right, so we can substitute 5 for the square root of, 3 square root of 6. All right, so this is the same as 3 times 5 plus 3 to the square root of 6. Okay, and we notice right here, all right, this is not a perfect square. If it's not a perfect square, then it's irrational. Okay, all right, so this 3 times 5 goes to 15 plus square root. Okay, so these, which looks like they might be kind of complicated when you started, are actually real simple to do. Square root of 6. All right, and again, the result's irrational because we have a square root in our answer. So if there is a radical in our answer, that is going to be irrational. Yes. Okay. Good luck with those, and don't give up.